takes 15 trucks to carry 160 boxes of cargo. How many trucks will it take to carry 970? So here's our conversion factor. We know that 15 trucks equals 160 boxes. So 970 boxes, we want to know how many trucks is that. So we set it up with X in the top just because it's easier to solve that way. And then we put the boxes in the bottom. Trucks in the top, boxes in the bottom. Then multiply both sides by 970 to get X by itself. And let's see what we get. So 15 times 970 divided by 160 is 90.9. So if you want to carry this, you better round it up to 91 trucks. And that's an example of proportional reasoning, how we set up one proportion that we know, and then we set up the unknown over here. So this comes out of your book. There are charts that remind you of what giga and mega and kilo and micro and nano actually all stand for. You're not expected to memorize that, but you're expected to know that it exists so that you can go through and find them. So there's also a chart in your book in lesson 5 that does imperial units, so feet, inches, yards, and miles. Again, you're not expected to memorize it, but you should be able to go back to this chart and use these values. So as a reminder, this is a megaliter and this is a milliliter. So if I go back to my chart, I just want to check what megaliter actually means. So mega is 10 to the 6. So 10 to the 6. And milli, if I go to my chart, is 10 to the negative 3. And liters would be right in the middle. So then how do we do this conversion? So there's two ways to do this. You can use a number line or you can use unit analysis. So on the number line, what you need to understand, if you're going from 10 to the 6 to 10 to the negative 3, you're actually doing 9 steps, 9 powers of 10, or 9 steps in the right direction. Because the reason is that this decimal place is going to move to the right, and there's a lot of milliliters in 1 megaliter. So what you could do is you could move that decimal place 9 steps to the right. And what you would get is 8 zeros, 6, 7, 8. 8 zeros, and then this would be your 9th step. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is the correct answer if you understand that there's 9 steps between mega and milli. It's not my preferred method of doing it though. Here's how I would probably do it, by unit analysis. So I started with 3.1 megaliters. And I understand that there are 10 to the 6 liters in 1 megaliter. So 1 megaliter is 10 to the 6 liters. But I'm going to put the megaliters in the bottom because I want the megaliters to cancel out, and I'll put liters in the top. So 1 megaliter is 10 to the 6 liters. And then I also understand that 1 milliliter is 10 to the negative 3 liters. It's very small. But when I put in my conversion factor, I'm going to make sure to put the liters in the bottom. Why? Because I want the liters to cancel out. One in the top, one in the bottom. So 10 to the negative 3 liters is 1 milliliter. And now we can start to cancel out our units using unit analysis to see if we are indeed left with milliliters. So the megaliters cancel out, the liters cancel out, and we will be left with 1 milliliter. So all I got to do now in my calculator is I have to type these pieces in. Now this, you got to remember, is this. That's what that means, 10 to the negative 3. If you wanted to, you could literally put 10 to the power of negative 3, and you would get that. So 3.1 times 10 to the power of 6 divided by 10 to the power of negative 3. And I'm getting the exact same thing in my calculator that I got here in green, which is 3.1 with 8 zeros behind it. Now, depending on your calculator, they might have put it in scientific notation, 3.1 times 10 to the 9. So if you see this in your calculator, that's what this means. But never write this down on a piece of paper. Always write it like this. So I'm going to do it my preferred way. which is by unit analysis. So we start with 27.5 micrometers. And I want to try and kill the micrometers, so I'm going to put the micrometers in the bottom. Here's my conversion factor. 1 micrometer is 10 to the negative 6 meters. What about this conversion factor? You need to know that there's 1,000 meters in 1 kilometer. And when you set up the fraction, be strategic. Put the meters in the bottom so that the meters will cancel out. So 1,000 meters, 1 kilometer. And we just check to make sure top and bottom cancel out. So I'm going to start typing this in my calculator. I'm going to put 27.5 times 10 to the power of negative 6. And then I'm going to multiply, or divide that rather, by 1,000. So here's what my calculator says. It says 2.75 e negative 0.8. That's what it says. Do not write this on your sheet of paper. This is 2.75 times 10 to the negative 8. And yes, we started with 27 and they moved the decimal place because in scientific notation, the decimal goes right after the first digit. So that's fine. You can leave it like this. This is the answer, but different. So this is asking you to convert kilometers per hour into meters per second, which is a bit harder because there's 2 units you have to deal with. So here's 65 kilometers per hour, which is what we started with. We need a couple conversion factors. We need to know that there is 1,000 meters in 1 kilometer. You also need to know that there's 3,600 seconds in 1 hour. So those are the 2 conversion factors you're going to use. It doesn't matter which one you use first. The careful part you have to be is like when you're setting up where the kilometers fall. So because the kilometers are in the top, I'm going to put the kilometers in the bottom here. So 1,000 meters in 1 kilometer. Then I'm going to use my other conversion factor, and I'm going to try and get the hours canceled out. But because the hours is in the bottom, I'm going to put the hours in the top so that the hour and the hour will cancel out. So 1 hour and 3,600 seconds. If I cancel out the units, hours and hours cancel out, kilometers and kilometers cancels out. So in the end, I will be left with meters in the top, seconds in the bottom. Is that what I wanted? Yes. So we're going to end up with some sort of meters over seconds. 65 times 1,000 divided by 3,600, and I'm getting 18.1 meters per second. So when you're trying to go from grams to kilograms, you would be expected to know that 1,000 grams is 1 kilogram. You'd also be expected to know that 1,000 milliliters is 1 liter. So when I go and set this up, 46 grams over liters, just be careful how you make up these fractions. Grams is in the top, so I'm going to put grams in the bottom so that they cancel out. And then the other one, liters is in the bottom, so I'm going to put liters in the top so that they cancel out. Let's see. Grams in the top, grams in the bottom. Liters in the top, liters in the bottom. I'll be left with kilograms and milliliters. Is that what I wanted? Yes. So kilograms per milliliter. Let's see. 46 divided by 1,000. Divided by 1,000 again. I am getting 4.6 e negative 0.5, but I am not going to write that. I am going to write 4.6 times 10 to the negative 5 kilogram per milliliter. So let's take a look at the conversion factors we're using here. Milliliters to liters. So I know that there's 1,000 milliliters in 1 liter. And then seconds and hours. So 3,600 seconds in 1 hour. Let's take a look. 6.2 milliliters per second. And I want to kill off the milliliters, so I'll put milliliters in the bottom. So 1,001. And then I want to kill off my seconds, so I'll put seconds in the top. 3,600 in 1 hour. Let's see. Milliliters cancel. Seconds cancel. I'm with liters and hours. Is that what I wanted? Yes, that is what I wanted. Liters per hour. Let's see. Okay, so 6.2 divided by 1,000 times 3,600, 22.32. If you got it wrong, you flipped something. Something got flipped, and I'm willing to bet it's probably this one. So this is where things get kind of ugly, which is imperial units. What is happening with these imperial units? So firstly, we need to go back to our chart and check out what's going on here. So on the chart, I need some information about feet and inches. So 1 foot is 12 inches, okay? So I'm going to write that down because I'm going to need that information. So 1 foot is 12 inches. And then I'm going to go back and I'm going to see if there's a conversion that will take me into meters. Let's see. So feet into meters. This will take me into meters. Okay. So 0.3048 meters in a foot. And I do not think that there is a convenient conversion that will take me from inches into feet or inches into meters. So these are our two conversion factors. I'm going to add one more conversion factor just to show that we have options here. A conversion factor is an inch is 2.54 centimeters. So we have these conversion factors at our disposal. So can we use these to figure out this problem? There are two strategies that we can do. We can either convert this entire thing into feet and then go to meters from there using this conversion factor. Or we can convert this entire thing into inches and then go to centimeters and meters from there. So there's two ways to do it. I'm going to show you the green way first, and then we'll do the blue way. So if I want to convert this entire thing into feet, and you understand that 5 inches is a fraction of a foot, so I want to convert that 5 inches into feet. So there's 12 inches in a foot. So what you have then is 5 divided by 12, which is 0.4167. I'm just going to keep 4 decimal places. Feet. So actually, instead of writing 8 feet 5 inches, I could write 8.4167 feet. And then we could take that and multiply it by our conversion factors to get into meters. So 1 foot is 0.3048 meters. So 8.4167 times 0.3048. So I'm getting 2.57 meters in the green case. If you want to do this in the blue case, you got to convert this into inches. So 8 feet with 1 foot equal 12 inches. So we're going to multiply. So 8 times 12 is 96 inches. So instead of writing 8 feet 5 inches, what I really should write is I should write this in inches. So 96 plus the 5 inches is 101 inches. And then I will use the blue strategy. I'm going to go to centimeters. 1 inch, 2.54 centimeters. And then 100 centimeters and 1 meter. And the centimeters cancel and the inches cancel. So let's see. 101 times 2.54 divided by 100, and I am getting 2.57 meters. So either way, you're going to get the exact same answer. So there are pros and cons to the green strategy versus the blue strategy. I personally prefer the blue strategy a little bit more, even though it looks like there are more steps to it, because I don't have to deal with this decimal. I don't want to have to write long decimals like this. I'd rather convert it all into inches first. But it really is your personal preference. The more decimal places you write, the more likely you are to make a copying error, which is a problem. So that's why I like this strategy better. The other problem with decimals is that I had to round it. And every time I have to round it, I feel a little bit gross about the accuracy of my final answer. But in this case, if you keep 4 decimal places, you're probably going to be okay.